Hello, you magnificent mathematicians. Let's get into our new unit, which is all things volume. I did just go ahead and fill everything in from the beginning, just so maybe today it's just like heavy front loading, but then the lessons throughout the unit will seem easier. I don't know. Let's try it. Let me know how this goes. But what we're specifically focusing on today is going to be 8.7a, which is solving problems involving the volume of cylinders, cones, and spheres. And today we're actually specifically just talking about cylinders. So basically we're just going to substitute known values into the proper formula and solve. Boom, done. The vocab terms you need to know are going to be this first one, area of the base, which is the area of the shape that classifies the object, like rectangular prism, triangular pyramid. We are talking about cylinders, which is a 3D figure with two parallel congruent circular bases. You guys already know what diameter is. That's a line segment that passes through the center of a circle, meaning from edge to edge, it is all the way across the circle. Whereas a radius is a line segment from one endpoint at the center of the circle to the edge. So half of the circle. You also already know what pi is. It's a ratio of circumference to diameter. And then lastly, we need to know what the height is, and that's the distance from base to vertex or base to base. You know, the distance between the two bases. Your formulas, you actually should already know and be able to write down from memory, but today the specific formulas we're working on is area of a circle. Capital B, area of the base, is pi r squared, or pi times r, and then we are finding the volume of a cylinder, which the formula is capital B times H. So the area of the base times the height. Boom, done. Cool. I hope you pause it at some point to copy all the things down, and let's get into it. Go to page 3. Volume of cylinders. Volume is the amount of space an object takes up or it occupies. For example, how much soda is in a soda can? Or how much soup is in a soup can? Our formula is V for volume equals B, which we know to be the area of the base, times the height. So these steps should seem really familiar. In fact, you already have them in your Unit 10 notes. First thing we're going to do is set up a T-chart. You're welcome. These are all set up for you, but yes, on your own practice, you'll have to set up your own. And then we are going to pull out the volume formula that we are asked for from the STAR reference sheet. Then we're going to shade in the base shape, highlight the height, plug it in and mark it out because we won't be using it again. We are going to draw the base shape and label the radius. We care about that radius. Then find the area of the base shape by using the formula from the formula chart. If we're given the diameter though, just know that we divide by 2. Woo! Okay. Have we looked at the formula chart? We have not. So we are dealing with area of a circle, which has already been highlighted in purple, pi r squared. We are dealing with volume, that top purple line. It's a prism or cylinder. Capital V equals capital B times the height. So I'm going to go through and do example 1. And then clearly as I'm going through example 2, I will be asking you questions. Probably be asking you questions with example 1 as well. And then truthfully, I want you guys to try example 3. You know what? Shucks. I take that back. Example 1, example 3 we'll do together, and example 2 I'll have you guys probably do on your own. Cool. Let's get it. Example 1. This is a circular prism. And then I am finding volume. So I need to pull out my volume formula, which I know on my reference chart is right there. Capital V equals BH. And then since I'm dealing with a circle, I need to draw a circle. Cool. I like that. It fills it in. That's fun. And then pull out my dimensions and label. So this looks like it's going halfway, 4.9. So I know my radius is 4.9 and my height is 7.8, right? Because then that has to be 7.8. Cool. So capital B equals pi r squared. Sorry guys, I made this all too big. So in my calculator, I can just put straight pi, the pi butts in, and then in parentheses, 4.9 to the power of 2, which rounded to the tens is 75.4. Oh, I did not plug in my height right away. That's what I should have done, and then marked it out. Cool. So I'm doing 75.4 times 7.8, and then rounding to the hundreds comes out to 588.12 feet cubed, right? Because we're multiplying 3 numbers, cubic feet, finding volume. I feel like that's really simple. But you know what? Let's do another example together, and then I'll have you guys do example 2 on your own. Example 3. A cylinder has a diameter of 8.6 centimeters and a height of 17.9 centimeters. Find the volume. That's pretty straightforward. Let me cube it. I have 8.6 centimeters, which is my diameter, and 17.9, which is my height. So I know I'm dealing with a cylinder, which is a circular prism. It does say ask for volume, which is capital B times H. Drawing my circle, pulling out my known information. That's diameter is 8.6. It says my height is 17.9. So I'm going to plug that in immediately. Perfect. And then I need to find my B. Capital B equals pi r squared. Well, I don't know what r is. I know what my diameter is. So what do I have to do? Yes, you're correct. Cut it in half. So 8.6 divided by 2. 8.5 is 4. 6.5 is 3. I feel like that's simple. Plug it into my formula. So in my calculator, I'm literally just going to put pi button times 4.3 squared, which should come out to 58.1. Yeah? Is that what you guys got? So then plugging that in. To my volume formula. This should be a very large number. 1,039.99 centimeters cubed. Cool. Okay, I feel like you guys can do example 2 on your own. Follow the exact same things we did with examples 1 and example 3. I feel like they look very similar. Just do the same thing with example 2, and you'll get it. All right, cool. I hope you guys were able to get 352.1 inches cubed. If you didn't, look at my work, see what's different than yours. I'm gonna say the first thing I noticed was that they gave us the radius and the height, so I didn't have to cut anything in half. Just plugged everything in. Boom, shakalaka. There you go. I feel like that's easy peasy. If you were confused by anything that was done, please do not hesitate to ask a teacher. That's literally our job. Let us do our job. Ask for help. Okay, bye.